What if a simple blood test could tell you how many years you have left? What if a machine, not a doctor, not a fortune teller, could look inside your cells and calculate the true age of your body? That question is no longer science fiction. Scientists have built something called a longevity algorithm, and it is quietly rewriting everything we thought we knew about aging, health, and human lifespan. Most people believe aging is determined by the number on their birthday cake. But researchers now know that number tells only part of the story. Two people can both be 50 years old, and yet one of them might have the internal biology of a 35-year-old while the other carries the cellular wear of someone nearing 70. The difference lies in something far more revealing than chronological age. It lies in biological age, and the algorithms built to measure it are changing medicine forever. What the algorithm actually measures, the science behind longevity prediction, begins at the molecular level. Inside every human cell, there is DNA, the genetic code that makes each person who they are. As the body ages, a chemical process called DNA methylation begins to change the way genes are expressed. Methyl groups, which are tiny chemical structures, attach to specific regions of DNA and switch certain genes on or off. Over time, these patterns shift in predictable ways. Scientists discovered that by reading these methylation patterns, they could estimate how old a person's body truly is on the inside. This discovery gave birth to what are now called epigenetic clocks. The first of these was developed by UCLA professor Steve Horvath in 2013.
An idea for such a treatment. You will face a challenge.
His clock could estimate a person's chronological age with remarkable accuracy simply by analyzing methylation data from a blood sample. But researchers quickly realized something even more powerful was hiding in that data. The clock was not just reading age, it was reading biological destiny. Newer versions of these clocks, such as GrimAge and PhenoAge, were designed specifically to predict mortality and disease risk. They do not just ask how old someone is, they ask how well someone's body is holding up, and how likely that person is to develop serious illness or die within a given window of time. The most cutting-edge version currently in wide use is called Dunedin-Passy, developed from a long-running study of individuals in Dunedin, New Zealand. This clock does not just measure where a person stands biologically, it measures how fast they are aging in real time. A Dunedin-Passy score of 1 means a person is aging at a normal rate. A score below 1 means their biological clock is ticking more slowly than average. A score above 1 means the body is aging faster than it should. Researchers at King's College London took this science even further. They trained 17 different machine learning algorithms on blood metabolite data from over 225,000 participants in the UK Biobank. These participants were between 40 and 69 years old at the time they were enrolled. The study, published in Science Advances, produced what they called mile-age, a metabolomic age that compares the internal chemical activity of a person's body against their actual years on Earth. The gap between these two numbers, what researchers called the mile-age delta, reveals whether someone is aging faster or slower than expected. It is one of the most ambitious longevity prediction efforts ever attempted, and it demonstrated clearly that non-linear machine learning algorithms outperform traditional models in capturing the true signals of aging. Meanwhile, Stanford researchers discovered that human aging does not happen gradually and smoothly. Instead, it appears to occur in distinct waves, with major biological shifts happening around the ages of 40, 4, and 60. These are windows during which metabolism, cardiovascular markers, and immune function change dramatically. Understanding these waves could allow future algorithms to predict disease risk before symptoms ever appear. How celebrities are using this science, the idea that biological age can be measured, tracked, and potentially changed has captured the imagination of some of the world's most high-profile individuals. Among the most well-known is Brian Johnson.
But it's worth it, so stick with it. It just takes some time to build the muscles. So the 5 things are, first,
a tech entrepreneur who sold his company to PayPal for $800 million and then dedicated much of his fortune to what he calls Project Blueprint, an obsessive, data-driven attempt to slow and reverse aging. Johnson submits himself to continuous biological age testing using the TrueAge platform, which measures DNA methylation patterns across multiple epigenetic clocks simultaneously. His published Dunedin-Passy score sits around 0.69, meaning that for every calendar year that passes, his body accumulates only about 8.5 months of biological wear. He reportedly spends over $2 million annually on his protocol, which includes a strict plant-based diet, a compressed eating window, intensive sleep optimization, and dozens of supplements. His organ-specific results have drawn particular attention. Published data suggests his heart and lung tissue register as biologically much younger than his chronological age. However, scientists have urged caution in interpreting these figures too literally. Dr. Morgan Levine, who pioneered some of the most advanced epigenetic clocks in use today,
to some of the diseases we see with aging, women tend to spend more time
has pointed out that these tools capture a single moment in time. They are powerful estimators of health trajectory, not precise calendars of death. The clocks, she explains, are important tools for understanding relative risk, but they cannot be converted directly into a guaranteed number of years. Harvard geneticist Dr. David Sinclair has taken a similar approach to self-monitoring. Sinclair, who serves as a professor in the Department of Genetics and co-director of a major aging research center at Harvard Medical School, has long maintained that his biological age is roughly a decade younger than his chronological age of 54. His approach includes intermittent fasting, a predominantly plant-based diet, and targeted supplementation. Sinclair famously told a major publication that birthday candles do not reveal how many years a person has left. Only the biology inside the body can begin to answer that question. Peter Diamandis, founder of the X Prize Foundation, recently launched a $101 million competition for research teams capable of developing therapies that can restore a measurable decade of human youth. The fact that a competition of that scale now exists signals how seriously the scientific and entrepreneurial worlds are taking longevity prediction and intervention. What this means for the rest of us. The longevity algorithm is not a tool reserved for billionaires or elite researchers. The same epigenetic testing platforms used by Brian Johnson are available to the general public. A comprehensive biological age test can be ordered directly and completed at home with a small blood sample. The results can reveal organ-specific aging patterns, overall biological age relative to chronological age, and metabolic markers linked to disease risk and mortality. More importantly, the research makes one thing absolutely clear: biological age is not fixed. It is not a sentence. Factors like smoking, alcohol consumption, physical inactivity, chronic stress, poor sleep, and a diet heavy in processed food all accelerate the biological clock. Conversely, regular exercise, strong social relationships, a plant-rich diet, quality sleep, and effective stress management are all measurable in their ability to slow biological aging down. A Chinese study tracking nearly 24,000 older adults found that lifestyle factors, including exercise, smoking history, and social activity, were among the strongest predictors of remaining lifespan. Another large European study identified marital status, mobility, and self-rated health as key variables linked to who lives longer than their age peers. The data consistently shows that while genetics accounts for roughly a quarter of lifespan variation, the rest belongs to the choices people make every single day. What the algorithm ultimately reveals is not a fixed number written in the stars. It reveals a direction, a trajectory shaped by daily decisions. The longevity algorithm does not predict fate. It predicts the path a person is currently on, and paths can always be changed. The body is not a train on a fixed track. As one UC Berkeley researcher put it, it is a system capable of repair, renewal, and redirection, and science is now providing the map to navigate it better than any generation before.